In this video, you will learn how to solve a quadratic equation by the quadratic formula and use the discriminant to determine the number and nature of the roots. Let's first go over solving a quadratic equation by the quadratic formula. Recall that the general form of a quadratic equation is ax squared plus bx plus c equals 0. The solutions to a quadratic equation can be found by the quadratic formula. X equals negative b plus or minus the square root of b squared minus 4ac all over 2a. To solve a quadratic equation, first rewrite the equation in the general form, ax squared plus bx plus c equals 0, if it is not already in that form. Second, determine the values of a, b, and c. Then, substitute the values of a, b, and c into the quadratic formula. Last, simplify the expression. Let's look at an example. Determine all solutions of the equation 3x squared minus 2x equals negative 1. The first step is to rewrite the equation in the form ax squared plus bx plus c equals 0. Adding 1 to both sides gives 3x squared minus 2x plus 1 equals 0. The second step is to determine the values of a, b, and c. For this equation, a equals 3, b equals negative 2, and c equals 1. The third step is to substitute the values of a, b, and c into the quadratic formula. Recall the quadratic formula. Substitution of a equals 3, b equals negative 2, and c equals 1 into the quadratic formula gives the result shown. The last step is to simplify the expression. Performing all operations gives x equals 2 plus or minus the square root of negative 8 all over 6. The square root of negative 8 can be rewritten as 2I times the square root of 2. Reducing the fraction then gives x equals 1 plus or minus I square root of 2 all over 3. So, the solutions to the equation 3x squared minus 2x equals negative 1 are x equals 1 plus or minus I square root of 2 all over 3. Notice that for this equation, substituting the values of a, b, and c led to a negative value underneath the square root. This led to two complex roots. We'll now see how the value underneath the square root can be used to determine the number and nature of the roots. Recall the quadratic formula. The expression underneath the radical in the quadratic formula is called the discriminant. The value of the discriminant gives the number of solutions to the quadratic equation. As we saw in the previous example, if b squared minus 4ac is less than 0, this results in two complex solutions and no real solutions. If b squared minus 4ac equals 0, the square root will have a value of 0, and this results in one real solution, namely x equals negative b over 2a. If b squared minus 4ac is greater than 0, the square root will have a real number value, so the equation will have two real solutions. Now let's look at another example. Identify whether each equation below has two real solutions, one real solution, or no real solutions. Remember that a quadratic equation has two real solutions if b squared minus 4ac is greater than 0. One real solution if b squared minus 4ac equals 0, and no real solution if b squared minus 4ac is less than 0. Let's look at the first equation. The equation is already in the form ax squared plus bx plus c equals 0. So a equals 2, b equals 2, and c equals negative 1. Substituting into b squared minus 4ac gives 2 squared minus 4 times 2 times negative 1. Simplifying results in 12, which is greater than 0. So the equation has two real solutions. Let's look at the second equation. The equation is already in the form ax squared plus bx plus c equals 0. So a equals 1, b equals -1, and c equals 8. Substituting into b squared minus 4ac gives -1 squared minus 4 times 1 times 8. Simplifying results in -31, which is less than 0. So the equation has no real solutions. Let's look at the third equation. We first need to write this equation in the form ax squared plus bx plus c equals 0. Adding 9 to both sides of the equation gives x squared plus 6x plus 9 equals 0. This means that a equals 1, b equals 6, and c equals 9. Substituting into b squared minus 4ac gives 6 squared minus 4 times 1 times 9. Simplifying results in 0. So the equation has one real solution. Let's look at the last equation. We first need to write this equation in the form ax squared plus bx plus c equals 0. Subtracting 3x from both sides of the equation gives 4x squared minus 3x equals 0. This means that a equals 4, b equals -3, and c equals 0. Substituting into b squared minus 4ac gives -3 squared minus 4 times 0. Simplifying results in 9, which is greater than 0. So the equation has two real solutions. Now you know how to solve a quadratic equation by the quadratic formula and use the discriminant to determine the number and nature of the roots. Thanks for watching.